my name is Vakas, and in this video I will introduce you to a library called Fluent Validation that will make it much easier for you to write simple as well as complex validation rules. You will find that writing the validation code using the Fluent Validation library is not only more enjoyable, but it's also easier to write, understand and maintain. Before we go further, let's quickly go through what you will learn in this video. First of all, I will give you a quick overview of Fluent Validation Library. I will explain you some of its key features. I will show you how to install Fluent Validation Library and related packages via NuGet Package Manager. I will then show you how to create, register and test validators. Additionally, I will show you how to validate the complex properties and collections. Let's dive in and make your validation process easier and more efficient. Fluent Validation is one of the most popular open source libraries for .NET developers. It allows developers to validate their models in clean, expressive, and fluent manner using the strongly typed validation rules. Here are some of the examples of custom validation rules. The first rule ensures that the name property of the user is not empty, and if it's empty, it configures a custom error message. It also checks that the name property of the user is between 2 to 50 characters. If this condition is not met, then it configures another custom message. The second rule checks the email property and makes sure it's provided, and also check if it's a valid email, showing appropriate error message if either rule fails. The first feature of Fluent Validation Library is that it provides a Fluent API to developers to write the validation rules. Developers can use this API to write the validation rules using the Fluent syntax, which makes their code concise and easy to understand. Fluent syntax is a method of chaining multiple method calls together in a more readable and expressive way. It makes the code more concise because multiple actions can be performed in a single line using a chain of methods. Most .NET developers are already familiar with the Fluent syntax because of the link queries and entity framework code they write in their .NET applications. So writing the validation rules in Fluent API doesn't seem complex to them. Fluent Validation Library provides a wide range of pre-built validators to handle most of the common validation scenarios. You can visit the Fluent Validation docs to check the full list of built-in validators. Another feature of this library is that it's fully extensible. It allows developers to create custom validators to handle their unique and advanced validation needs beyond the built-in options. The example of custom validators can be a password validation length. It's very common validation these days to force users to provide strong passwords, which contains at least one uppercase letter, one lowercase letter, maybe one special character, or one number. Another custom examples could be a unique value validation, which can be used to verify that the username or the email provided by the user in an input field is unique by checking against the database. Fluent Validation Library also supports conditional validation, which means your rules can be applied only when certain conditions are fulfilled. Here is an example of conditional validation where I'm using when and the otherwise built-in methods of Fluent Validation Library. We are creating a rule to make job title property required property only when user is employed property is true. Otherwise, it will be treated as an optional property. To install the Fluent Validation Library, we need to download some NuGet packages. The main package is called the Fluent Validation package, and it has all the core functionality to write the validation rules using this library. If you are building an ASP.NET Core application, then you also need to install the Fluent Validation.ASP.NET Core package. This package extends the Fluent Validation library to enable validation within your ASP.NET Core controllers. There is another package called Fluent Validation.Dependency Injection Extensions, and this package is useful to integrate the Fluent Validation library with Microsoft built-in dependency injection framework. To install these packages, you can use the install package command inside the VL Studio Package Manager console. Let's say you have a customer model class in your application which looks similar to this, and you want to validate the properties of this class using the Fluent Validation library. Fluent Validation Library has a class called Abstract Validator that can be used to define the custom validation rules against any model or class you want to validate. You need to create a class that inherits from this generic Abstract Validator class, and then you can specify the model or the class you want to validate. In our case, it's a customer model class. Custom validation rules can be defined in the constructor of the class. To specify a validation rule against a certain property, you can use the built-in method rule4 by passing the lambda expression that specify the property you want to validate. For example, to ensure that the first name and the last name properties are not null or empty, we are passing them as an expression inside rule4 method. And then we are using the two built-in methods not null and not empty to make sure that the first name and the last name property values are provided. The not null validator ensures that the value of the property is not null, and not empty validator ensures that the value of the property is not null, an empty string, or a white space. Validators can be used with any dependency injection library such as Microsoft.extensions.dependency injection. To inject the validator of a specified model, we need to register it with the service provider using the iValidator interface where T is the object being validated. In our case, it's a customer model class. This registration ensures that whenever the application needs to validate customer model class, the dependency injection container will provide an instance of customer validator to validate that model. If you have a large application with hundreds of validators, then registering them all one by one doesn't seem a good idea. FluentValidation.dependency injection package has a built-in method called addValidators from assembly container that can be used for automatic registration of multiple validators. This method will scan the assembly in which the customer validator is defined to find all the validators, then it will register them all with the service provider. We have gone through enough slides by now. It's time to jump into the code and see everything in action. I have created an ASP.NET Core project using the .NET 8, and the first thing we need is to install the packages. I'm inside the package manager console, and the first package we need to install is a main Fluent Validation library. The next package we need to install is a Fluent Validation.ASP.NET Core package. The last package we need to install is dependency injection extensions package. We are now ready to create our first customer model class. I'm going to create a customer model class inside my models folder, and in this class we will create the properties of the customer. For example, I'm creating a first name property, the last name property, and then we have an email property. The next one we need is a decimal type property height. Then we need an integer property age, and finally we need a phone property. I have already created a customer controller with the two action methods. The first action method is the get action method that will display a create customer page to the user. And the second action method is the HTTP post method where we will be submitting the customer data when the user will click the create button. I have also implemented the view of this controller, which is a simple ASP.NET form using the ASP.NET validation attributes. I have created a validators folder in my project, and inside this folder I am creating a class customer validator. As we already know that we need to inherit this class from the abstract validator, and inside I need to pass the customer model. Now we are inside the constructor, and here we can define the validation rules. The first business rule I'm going to define is to make sure that the first name property of the customer model is required, and if it's not provided, I want to display some message to the user. In the third business rule, I want to validate my email property, and here I'm also using another built-in validator to make sure that the email address is valid, and if it is not valid, I will be displaying a different error message. Fourth rule I'm going to define is the height property, and here I'm using the same not empty validator, which will make sure that the height property is required. Then I'm also using another built-in validator, precision scale. It basically enforces two different rules. The first, it will make sure that you have 2 digits before the decimal point, which is your precision, and then it will also make sure that you have at least 1 digit after the decimal point, which is your scale. And the third parameter, which is a Boolean parameter, decides whether you want to ignore the trailing zeros or not. I'm also displaying a different error message if this precision scale is not enforced. Next, I'm creating another business rule to add some validation on the age property, and in this rule I'm using a built-in validator inclusive between. This validator can enforce the range on some integer property. Here in our case, it will make sure that the age age property is between 18 and 15. If user will provide an age that's not inside this range, we will be displaying another error message. The last rule we need to define is to validate the phone property. Here I'm using a built-in validator must, which allows you to define the validation rules using the lambda expressions. Here in this case, I am enforcing a business rule to make sure that the phone value is always starting with the plus sign. If you will run this application right now, nothing will happen because we haven't registered the validator yet. So let's go to the program file and register the validator. You need to make sure that you are registering the validator after the add controllers or add MVC or add controller with views method. To register the validator, you need to add the iValidator interface to the services collection. And here you need to provide your customer model and the customer validator. To make sure that the Fluent validation is integrated properly with the ASP.NET Core validation pipeline, you also need to call another method, add Fluent validation auto validation. Let's just run this application and see how our validation rules are applied. I am inside the browser, and without providing any value, let's just hit the create button. As you can see, all the validation rules are enforced and validation messages are appearing with the fields. Let's test this further by providing some invalid email address and provide the age which is not inside the range of 18 to 50. And you can see now the different validation messages are displaying. So far, we are only validating the properties of the built-in types such as string, integer, or decimal. What if you want to validate a complex property of this model? A complex property is a property of custom type which can have its own properties. So in this case, let's define a property of a custom class. Let's say we have a class address model, primary address property, and now we need to define the address model class inside the models folder. The address model has its own properties like address line 1, address line 2, country, state, or the postcode. This model class is used as a property of the primary address inside the customer model. Now this primary address is a complex property, and there are different ways to validate this complex property using the Fluent validation library. First, you need to define the validator of this address model class. So let's create another validator inside the validators folder and call it address validator. And just like the customer validator, this validator will also inherit from the abstract validator, and it will be providing the address model as a type. For simplicity, let's just copy some basic validation rules to make some of these properties required properties. Now we need to validate this primary address property. So I'm back inside the customer validator class. To validate the primary address property of the customer validator, we can use the setValidator method that will accept address validator class instance as a parameter. Let's say you have a collection inside your model class. For example, here I am defining the other addresses as a collection of address model type. Now you would like to validate the entire collection of this address model class objects by using the same address model validator you have used with the primary address. To validate the collection, we can use the rule for each method available inside the Fluent validation library. In this method, you can validate the collection property using the same setValidator method. I hope you liked this video. If you're already using the Fluent validation library or planning to use this validation library, then drop me a comment. I will really appreciate if you can subscribe to my YouTube channel for more videos like this. Until next time, stay awesome.